PC Electronics. This is a video on ISRO Scientist Electronic Post Preparation. We are going to see the questions from Digital Electronics. Okay, so this is the part 2 of Digital Electronics subject. So let us see what are the questions. The first question is, in the following circuit, X is dash. So if you see, this is two mux interconnected and the output of the second mux is X. You need to write the equation for X. In terms of A, B and C, which are the select lines of these two muxes. Okay, so this is a 4:1 mux, 4:1 mux. This is also a 4:1 mux. So there are 4 inputs and 2 select lines for both the muxes. Okay, so how to solve such a question? You can go for either truth table method. That is, you can write a truth table of ABC inputs with 0, 0, 0, 0, 0, 1 likewise. Okay, so likewise you can do it, but that is a lengthy method. Now, if you see this muxes, you can observe that the inputs given to the muxes are in a particular order. That is, here it is 0, then 1, 1, then 0. Here also it is 0, then 1, 1, then 0. Okay, so what are these inputs corresponding to? That is, if the select lines are S0 and S1, S0 and S1 is given, then the inputs corresponding are, that is, if it is 0, 0, then input I0, then 0, 1, then I1, then 1, 0, then I2, and 1, 1, then the input is I3. That is, the I3 is selected if the select lines are 1, 1. Likewise, a 4:1 mux is working, right? So, this inputs are corresponding to 0, 0 select line, 0, 1 select line, 1, 0 select line and 1, 1. Here also 0, 0, 0, 1, 1, 0 and 1, 1. Okay, I'll just remove this 4:1. Okay. Now, so this is the select lines corresponding to the each of inputs I1, I0, I1, I2 and I3. And if you see, the inputs are only one for this I1 and I2, right? The I0 and I3 are 0. So, this mux is actually selecting the inputs I1 and I2, which is corresponding to your A and B, that is A bar B plus AB bar, right? For only this combination of select lines, the inputs are being selected, or I1 and I2 are being selected. So, the select lines are in the combination A bar B, A B bar for selecting I1 and I2. Okay. So, what is this expression corresponding to? That is, A bar B plus A B bar is corresponding to what? It is corresponding to a XOR gate, right? So, the Y is A XOR B. Okay, so this A XOR B is given to the select line S0 of your second mux, right? So here it is A XOR B is coming to your second mux. That is a select line of your second mux. And here again, the output is 1 for only 0, 1 and 1, 0 combinations of your select lines. That means here again, this XOR this, that is, if Y is taken here, then Y XOR C is the output of your second mux also, right? I am telling it again because the outputs of this mux are 1 for the input combinations or the select line combinations 0, 1 and 1, 0. Here also 0, 1 and 1, 0. So, the output of the first mux Y is A XOR B, where A and B are the select lines. Also, the Y, which is the output of the first mux, is taken as a select line S0 of the second mux. So, the select lines of the second mux is Y and C. And this output, the output of the second mux is also 1 for 0, 1 and 1, 0 combinations of your select lines, which corresponds to Y XOR C. So, your X, the result X is equal to Y XOR C. That means A XOR B XOR C is your result X. Okay, this is C. So, this is your result or your X value. Now, in the equation, they have expanded the the terms. That is, you cannot see any XORs. That is A XOR B XOR C, you cannot see. Now, what is the expression for? What is the expression for A XOR B XOR C? Option A is A B bar C plus A bar B C bar plus A bar B bar C plus A B C. This is the expansion for A XOR B XOR C. So the expansion for A XOR B XOR C is your option A, which is your result, that is X. Okay, so the correct answer for this question is option A. D input of a D flip-flop receives an input A XOR Qn, where A is an external logic input and Qn is the output of the flip-flop. The circuit works as dash. A XOR gate, B T flip-flop, C D flip-flop, D JK flip-flop. So here we are actually going to modify our D flip-flop. Okay, so this is a D flip-flop. This is the Qn, that is the output, then Qn bar. Okay, so here the question is saying that D input, which is this, of a D flip-flop receives an input A XOR Qn. So there is a XOR gate used here, and the XOR gate is actually A XOR Qn, where Qn is the output of the flip-flop and A is an external logic input. So this is an external logic input, and this output of this XOR gate is connected as a input to the D gate, the D terminal or the D point of the flip-flop. Okay, so this is a clock connected. So this is the output, and in the question they are asking the circuit work as dash. Whether it will be an XOR gate, whether it is a D flip-flop, whether it is a T flip-flop or a JK flip-flop. So for answering this question, we need to write a small truth table. Okay, so I'm going to write my truth table for the D flip-flop, where D is actually A XOR Qn and the output is Qn itself. Okay, so let us see how the value of Qn varies according to this XOR gate connected. So I'm going to take the values of Q and X and A and Qn as 0, 0, 0, 1, 1, 0 and 1, 1. Okay, so I'm going to give these combinations for A and Qn. So if 0, 0 is taken, the XOR value is 0. So if 0 is coming, then the output is also 0. 0 and 1. The XOR value is 0 XOR 1 is 1. So the output is 1. Now 1 XOR 0 is 1. So the output is 1. Now 1 XOR 1 is 0. So the output is 0. So this will be actually the truth table of this particular circuit. That is a D flip-flop with a XOR gate at the input. Now if you see this truth table, you can see that first we have taken the values of A as 0, 0. Then we have taken the values of A as 1 and 1. Okay, so let this A be a control input. When this control input is 0, we have obtained the values of Qn as the previous Qn values itself, right? We have taken this Qn as 0 and 1, and when the control was 0, the output is 0 and 1 itself. When the control values are 1, that is when the values of A is 1, then the output is obtained as 0 for 0, the value is 1, and for 1, the value is 0. So what is actually happening? It is actually a toggle flip-flop, which depends on your control input or your input A. So when A is 0, the output of the circuit is, what is the output of the circuit? It is the same. When A is 1, it toggles your output. Okay, so this is actually happening. So this circuit is actually a what? It is actually a T flip-flop. I hope it is clear. So in order to answer this, I have just drawn a simple truth table where the D is your input and Qn is your output. This output actually depends on your what? On your XOR output. That is, the XOR gate is connected to the D input, and this XOR's output is depending on this D, and according to which your output finally will get varied. Okay, so I've just given the combinations as 0, 0, 0, 1, 1, 0 and 1, 1. And when I've made this A or the control, I'm just calling it as a control. This control as 0, then the output is your previous output itself. And when 1, 1 is given, the output is toggled. So this is a what? This is a toggle flip-flop. So you can replace this A as A is equal to T or your toggle input. Okay. So the correct answer for this question is option B, which is T flip-flop or toggle flip-flop. The next question is, which of the following circuits come under combinational circuits? 1. Full adder, 2. Full subtractor, 3. Half adder, 4. JK flip-flop, 5. Counter. So the the options are option A 1 only, option B 3 and 4, option C 4 and 5, option D 1, 2 and 3. Now, what is a combinational circuit? What is a sequential circuit? So, there are basically two categories of digital circuits, that are combinational circuits and sequential circuits. In a combinational circuit, this is a combinational circuit. So, here there will be some inputs and there are outputs. Let the input be X, let the output be Z, then Z is equal to a function of X. That is, here the output depends only on the present inputs. Now, what is a sequential circuit? This is a combinational circuit. If you connect a memory element to the output of this combinational circuit, or connect with a memory element with this combinational circuit, you will get a sequential circuit. That is, take this output and connect to the input with the help of this memory element. So this is the next state. This is the present state. So this inputs will be now external inputs. These are external outputs. And the memory elements will be receiving internal inputs from this output. Internal inputs. And from here, internal outputs. So this is a basic structure of a sequential circuit. So sequential circuits are actually combinational logic or combinational circuit connected with a memory element. Now, out of which all are the combinational ones, that is without memory elements, they are asking. So option A is a full adder. Full adder only depends on what? The given inputs. So whatever be the given input, we will get the corresponding addition result. So is it there any memory element in the full adder? No. So it is a what? It is a combinational circuit. Okay. Now full subtractor is also similar to the full adder. So it is again a combinational circuit. Now half adder, it is again a what? It is a combinational circuit. The next one is a flip-flop, that is JK flip-flop. All flip-flops are having memory elements. So it is not a combinational circuit. The last one is a counter. Counter is obviously a sequential circuit because it should know the previous count to increment or to count. Okay, so the counters are all sequential circuits. Okay, so the correct answer is the first three are combinational circuit. The last two are sequential circuit, that is not combinational circuits. So the correct answer for this question is option D, that is 1, 2 and 3. That is the full adder, full subtractor and half adder are combinational circuit, and the last two, that is JK flip-flop and counter, are sequential circuit. So the correct answer is option D is the correct answer. A 4:1 mux is used to implement a 3-input function, that is f of a, b, c. What is the function they are asking? So they have given in the terms of the ones present in the K map or the sigma terms they have given. Okay, so we need to actually draw the K map to answer this question. That is, in order to find in which all positions the one value is present, then only we can answer this question, right? So this is actually a what? This is a 4:1 mux. So the 4:1 mux is having two select lines B and C. and the inputs are I0, I1, I2 and I3, and I0 is given the value A and I1 is given A bar, and I2 is 1, I3 is 0. So the values of I1, I2, I3 is, I1 is actually corresponding to 0, 0, that is B bar, C bar. Then I1 is corresponding to 0, 1. I0 is corresponding to 0, 0. I1 is corresponding to 0, 1. I2 corresponds to 1, 0. And I3 corresponds to 1, 1. So you can write it here. 0, 0, 0, 1, 1, 0 and 1, 1. Right. This is a 4:1 marks. Okay. So I've written it inside the box. That is, your I0 input corresponds to your B bar, C bar or 0, 0. I1 corresponds to 0, 1. I2 corresponds to 1, 0. And I3 corresponds to 1, 1. Now, if you draw a 3-bit K-map, how will it be? A, B and C. This is a 3-bit K-map. This is 0 and 1, which corresponds to A bar and A. And this is 0, 0, 0, 1, 1, 1 and 1, 0. Okay. So, now just see the case for 0, 0. So, if B and C are given as 0 and 0, B and C are given as 0 and 0, what is the result? If B and C are given as 0 and 0, then I0 is selected, right? So, the value is A. So, when B and C are given as 0 and 0, then the value is A. So, here there is a 1. Now, when the value is given as 0 and 1, that is B bar C is given, or B and C are given as 0 and 1, then I1 is selected, or the value is A bar. So, here for 0, 1, the value corresponds to A bar. So, here there is a 1. Now, for 1, 0, the value is 1, that is I2 is given a 1. So, for 1, 0 combination of B and C, the value selected is 1. So, for 1, 0, the value is both 1 or a 1 is given as input. And for 1, 1, the value is 0. Okay, so there is no 1s here because 1, 1 is connected to a 0 input. Okay, so this is how the K-map look like. That is, the 3-bit K-map of this particular function f of ABC will look like this. Now, we need to find in which all positions the values are 1. So, here this corresponds to 0, there is no values. For 0, 1 or 1, the value is 1. Now, I'll write the answer here. So, for 0, 1 or 1, there is a 1. Now, for 3, there is no 1. This corresponds to 2. Here, this corresponds to 4, 5, 6 and 7, right? So, the last one is at 6. So, the ones are present at 1, 2, 4 and 6. Okay, so the function f of ABC corresponds to sigma 1, 2, 4 and 6. So, the correct answer for this question is option A, which is sigma 1, 2, 4 and 6. So, the correct answer for this question is option A. I hope you understood how to do this problem. This is by drawing of 3-bit K-map. So, it is specifically given in the question that for a 3-input function. So, also by seeing the options, you should be able to identify that you need to draw a K-map. So, this is a very simple question. By simply drawing a K-map, you can answer this question. Okay, so I hope this video was useful for your preparation. I hope you understood how to do the problems which we have discussed in this video. I have tried to make the video a little more difficult than the part 1 of the digital electronics subject. We will be doing more problems from various subjects for ISRO Scientist Electronic Post Preparation in the upcoming videos. Okay, so if you want to see more videos, please do subscribe to the channel. And if you found this video useful for your preparation, Please do give it a thumbs up and also share this video with your friends. Hope for watching and keep on watching.